December 15th, 1944. EO 347 hours. Frozen fields outside Bastogne, Belgium. Snow fell in thick curtains through the pre-dawn darkness, muffling sound and reducing visibility to mere yards. Obergefreiter Klaus Dietrich of the 26th Volksgrenadier Division pressed himself deeper into his foxhole, watching American artillery impacts bloom like deadly flowers across the landscape ahead. What happened next would shatter every assumption he and his comrades held about American infantry capabilities. Through the smoke and chaos of the heaviest bombardment he had ever witnessed, mechanical shapes emerged from the inferno, carrying soldiers who should have been dead or scattered. The Americans had just demonstrated a capability that would fundamentally alter how infantry warfare was conducted. And what Dietrich couldn't know was that he was witnessing the culmination of America's most successful mechanized infantry program. The German forces had just encountered the M3 half-track in its intended role, delivering fresh troops directly through artillery fire that should have made infantry movement impossible. The strategic situation in December 1944 painted a picture of desperate German gamble against overwhelming American material superiority. Hitler's Ardennes offensive, later known as the Battle of the Bulge, represented Germany's last major attempt to split Allied forces and force a negotiated peace. German commanders understood they faced enemies with unlimited resources, but they believed winter weather would neutralize American advantages in air power and mechanized mobility. Traditional military doctrine suggested that concentrated artillery fire created zones of death where infantry could not survive, much less advance in organized formations. German forces had experienced this reality repeatedly on the Eastern Front, where Soviet artillery barrages preceded infantry assaults by hours, allowing defenders to reposition or reinforce threatened sectors. American tactical doctrine, however, had evolved beyond these conventional limitations through industrial innovation and tactical adaptation. The development of American mechanized infantry capabilities traced back to pre-war observations of German blitzkrieg tactics, but American engineers and tacticians had drawn different conclusions about infantry protection and mobility. While German doctrine emphasized speed and concentration of armor, American planners focused on the vulnerability gap between artillery preparation and infantry assault. Traditional tactics required artillery to cease fire before infantry advanced, creating windows of opportunity for defenders to recover and reposition. American industrial capacity allowed for a different approach entirely. The M3 half-track, produced in quantities that German planners could barely comprehend, represented more than transportation. It embodied a fundamental reimagining of how infantry could operate in modern warfare. The M3 half-track program demonstrated American industrial methodology at its most effective. White Motor Company's production facilities in Cleveland, Ohio, along with Diamond T Motor Company and Autocar Company plants, produced 41,170 M3 variants between 1941 and 1944. Each vehicle required 8.5 tons of steel, 2,200 pounds of aluminum, and 450 pounds of rubber, materials that German industry could not spare for secondary applications. The half-track's armor thickness ranged from 6.35 to 12.7 meters, sufficient to protect against shell fragments and small arms fire while maintaining mobility across terrain that would stop wheeled vehicles. The vehicle's ground pressure of 7.8 pounds per square inch allowed operation in mud, snow, and soft ground conditions that immobilized conventional trucks. American training programs for mechanized infantry reflected the nation's systematic approach to military education. Fort Knox, Kentucky, and Fort Benning, Georgia, developed standardized curricula that trained 127,000 mechanized infantry soldiers between 1942 and 1944. Each soldier received 16 weeks of specialized training, compared to the 8-week programs that German forces had adopted by 1944 due to manpower shortages. American troops practiced coordination between artillery fire and mechanized movement for an average of 240 hours, developing the timing and communication skills necessary for advance under fire tactics. German forces, lacking sufficient vehicles for realistic training, could only theorize about countering such capabilities. The technical specifications of American mechanized infantry operations revealed capabilities that German intelligence had consistently underestimated. Each M3 half-track carried a standard squad of 12 soldiers plus crew, but more importantly, it provided mobile radio communication that maintained contact with supporting artillery throughout movement. The vehicle's maximum speed of 45 miles per hour on roads dropped to 25 miles per hour cross-country, still faster than infantry could advance on foot through contested terrain. The mathematics were undeniable. American mechanized infantry could cover ground at 3 times the rate of conventional foot soldiers while maintaining protection and communication capabilities that traditional infantry lacked entirely. The operational reality of American half-track employment demonstrated advantages that extended far beyond simple transportation. Vehicle-mounted radios allowed real-time coordination with artillery units, enabling the technique known as advance under fire, where artillery shifted targets continuously as infantry moved forward. American artillery doctrine had evolved to support this capability, with forward observers riding in laid vehicles to direct fire precisely ahead of advancing troops. The 105mm howitzers that provided this support fired an average of 47 rounds per gun per day during major operations, compared to German artillery units that averaged 12 rounds per gun due to ammunition shortages. German attempts to counter American mechanized infantry revealed the limitations of their defensive doctrine and equipment. Panzerfaust and Panzerschreck anti-tank weapons, designed to destroy heavy armor, proved excessive against half-tracks while exposing operators to return fire from multiple vehicles. German machine gun positions, positioned to engage foot infantry, found themselves outranged by vehicle-mounted weapons and vulnerable to rapid flanking movements. Most critically, German artillery operating with limited ammunition supplies could not sustain the continuous fire necessary to suppress American mechanized advances. The immediate tactical confusion among German forces became evident through intercepted communications and post-battle interrogations. Radio intercepts from the 26th Volksgrenadier Division during the Bastogne engagement revealed repeated requests for guidance on engaging armored infantry that continued advancing through defensive artillery fire. German tactical manuals contained no procedures for countering infantry that remained mobile and organized during artillery bombardment. Unit commanders reported to higher headquarters that American forces were employing new tactics that rendered traditional defensive preparations ineffective. Lieutenant Robert Morrison of the 11th Armored Infantry Battalion, 10th Armored Division, later described the psychological impact of advance under fire operations in his post-war memoir. The Germans would see us coming through their own artillery fire and just couldn't believe it. We'd dismount 50 yards from their positions while shells were still falling behind us. They expected us to be scattered and disorganized, but we came out of those vehicles ready to fight as a unit. The look on their faces when we appeared through the smoke was worth all the training we'd endured. Technical Sergeant James Patterson, radio operator in Morrison's company, recalled the precision required for successful operations. Everything depended on timing and communication. Our artillery would walk their fire forward at exactly 100 yards per minute, and we'd follow 200 yards behind. The half-track drivers had to maintain exact speeds, while the radio operators kept constant contact with the Fire Direction Center. One mistake in timing or communication could put us under our own artillery. Captain William Hayes, artillery forward observer, attached to mechanized infantry units, explained the innovation from the artillery perspective. Traditional doctrine called for artillery to cease fire before infantry advanced. We developed techniques for continuous fire support that moved with the infantry. Our 105 mm batteries could shift fire on 30-second notice, keeping suppressive fire on German positions until our troops were literally on top of them. The Germans never adapted to fighting infantry that came with their own artillery support. German documentation of Tiahuitesme encounters with American mechanized infantry revealed the psychological impact of facing unexpected capabilities. Obergefreiter Hans Müller of the 12th SS Panzer Division wrote in his diary on December 18, 1944, "The Americans attack in ways that make no sense. Their artillery fires continuously, but their infantry advances through it as if the shells cannot touch them. We prepare for the usual pause between bombardment and assault, but there is no pause. They emerge from the smoke already organized and ready to fight." Major Friedrich Hoffmann, operations officer of the 2nd Panzer Division, reported to his superiors on December the 20th, "American mechanized infantry tactics render our defensive doctrine obsolete. We cannot predict when artillery will cease and infantry will begin, because they occur simultaneously. Our positions designed to engage foot soldiers advancing across open ground cannot effectively engage troops who arrive in armored vehicles and dismount at close range." Captured German intelligence assessments from January 1945 revealed the strategic implications that enemy commanders recognized. A report from Army Group B headquarters acknowledged, "American industrial capacity has produced not merely vehicles, but an entirely new form of warfare. Their mechanized infantry combines the mobility of armor with the flexibility of foot soldiers, supported by artillery coordination that we cannot match with our current resources and training." Post-war interviews with German commanders provided additional insight into the capability gap. General Fritz Bayerlein, commander of Panzer Lehr Division, stated in 1947, "The Americans had solved a fundamental problem of infantry warfare that we had not even recognized. They eliminated the gap between artillery preparation and infantry assault that had defined tactics since 1918. Their half-tracks were not just transportation. They were a complete tactical system. The industrial might behind American mechanized infantry capabilities demonstrated the overwhelming resource advantage that determined the war's outcome. White Motor Company's Cleveland facility alone employed 47,000 workers, producing M3 half-tracks at peak production rates of 45 vehicles per day. The plant consumed 380 tons of steel daily, more than many entire German armament factories processed in a week. Quality control procedures required 127 inspection points per vehicle, ensuring reliability standards that German industry operating under constant bombing and material shortages could not maintain. American production statistics revealed abundance that German planners found impossible to counter. The United States manufactured 15 414 M3 half-tracks in 1943 alone, while Germany produced 12,063 armored vehicles of all types during the same period. American half-track production required 129,000 tons of steel in 1943, representing less than 0.2% of total American steel production. Germany's entire armored vehicle program consumed 847,000 tons of steel in 1943, representing nearly 8% of German steel production and limiting resources available for other military programs. The innovation pipeline that created American mechanized infantry superiority demonstrated systematic research and development capabilities that Germany could not match. Aberdeen Proving Ground in Maryland conducted 2,147 separate tests on half-track variants between 1941 and 1944, refining everything from suspension systems to radio mounting brackets. American universities contributed metallurgical research that improved armor quality while reducing weight, and automotive industry partnerships provided manufacturing expertise that accelerated production while maintaining quality standards. Resource abundance allowed American forces to employ half-tracks in ways that German commanders found wasteful but tactically devastating. American mechanized infantry units averaged 1 half-track per 12 soldiers, while German mechanized units averaged 1 armored personnel carrier per 40 soldiers when vehicles were available at all. American units could afford to use half-tracks for single missions, while German forces had to preserve vehicles for multiple operations due to replacement shortages. The immediate tactical changes forced by American mechanized infantry capabilities altered battlefield dynamics across all theaters. German defensive doctrine, based on creating killing zones between prepared positions, became obsolete when American infantry could traverse these zones under armor protection. Traditional concepts of fire and maneuver required revision when one side possessed mobility and protection advantages that the other could not counter. Enemy doctrinal adaptations proved inadequate due to resource and training limitations. German attempts to develop similar capabilities produced the SD-KFZ 251 series, but production totaled only 15,252 vehicles throughout the entire war compared to 41,170 American M3 variants. More critically, German forces lacked the artillery ammunition and communication equipment necessary to replicate American advance under-fire tactics. The cascading effects on other military systems demonstrated how single innovations could transform entire operational concepts. American mechanized infantry success encouraged development of specialized variants, including mortar carriers, command vehicles, and medical evacuation platforms. These developments created integrated tactical systems that German forces could not match with their limited industrial capacity. Strategic realignment following recognition of American mechanized infantry capabilities forced German commanders to abandon offensive operations and focus on defensive preparations that proved inadequate. Resources diverted to anti-tank weapons and defensive fortifications reduced availability for other critical military programs. The psychological impact extended beyond immediate tactical effects, convincing German leadership that American industrial superiority made ultimate victory impossible. The morale impact on both sides reflected the broader implications of technological and industrial disparities. American forces gained confidence from possessing capabilities that enemies could not counter, while German troops faced the demoralizing reality of fighting opponents with unlimited resources and continuous innovation. Propaganda value proved significant as news of American tactical innovations spread through military and civilian populations. Enemy attempts to counter the psychological effects through propaganda and tactical adjustments failed due to underlying resource limitations. German forces could not demonstrate equivalent capabilities, and tactical countermeasures proved inadequate against systematic American advantages in equipment, training, and support. The verdict of history confirmed that American mechanized infantry capabilities represented more than tactical innovation. They embodied the industrial and technological superiority that determined the war's outcome. The M3 half-track program demonstrated how American manufacturing capacity could transform military concepts that other nations could only theorize about implementing. German forces at Bastogne and throughout the Ardennes offensive encountered not just new equipment, but an entirely different approach to warfare, made possible by unprecedented industrial resources. Post-war analysis by German commanders acknowledged the decisive impact of American mechanized infantry on the war's outcome. The capability gap revealed at Bastogne and similar engagements convinced German leadership that continued resistance was futile against opponents who could continuously innovate and produce new military capabilities. The half-track program's success influenced post-war military development worldwide and established principles of mechanized infantry operations that remain relevant today. What Obergefreiter Dietrich witnessed in those frozen fields outside Bastogne was more than tactical surprise. It was the manifestation of American industrial democracy's ability to transform warfare itself. The soldiers emerging from that artillery-swept landscape carried with them the full weight of a nation's industrial capacity, technological innovation, and systematic military development that no enemy could hope to match. Like and subscribe for more incredible stories of American military innovation and the industrial might that changed the course of history. Share this video to help others discover these amazing tales of technological superiority.